Here is video 3.5 day 1 slope-intercept form. We just finished 3.4, which is our graphing with just intercept form. So last time we had the x-intercept and the y-intercept. We found those 2 points and we connected them. This form, slope-intercept, is like 10 times more popular. This is our two things that we need, the slope and the intercept. We can find those two things, we can graph just about any linear function that we can think of easily. Slope-intercept form always follows the same type of form. Y equals mx plus b. Or every once in a while, you'll see y equals b plus mx. Now these two things are secretly the same thing. 3 plus 5 is the same as 5 plus 3. So really these are the two exact same way of saying it. But this will be the same thing with m and b being numbers. So for example, you might see an equation that would say y equals 3x plus 4. So in this case, m is on the x value, so 3 is my slope. 4 doesn't have the x on it, so that's the intercept. If there's ever anything over here with the y, that tells me that that's not in slope-intercept form. Really important to remember that slope-intercept form always has y equals. The other vocab word that we're going to look at is the slope itself. So we've talked about intercept, and we know what that is, and we'll talk a little bit more about how this 4 is secretly an intercept. But what is slope itself? Now, I don't know who you all had for your 8th grade math, but the people that I've talked to have really impressed me with the way you guys talk about slope. But just as a refresher, slope is always our change in x over our change in y. Goodness. So it's our change in y over our change in x. Another way of saying that is it's the rise over the run. In the example that I just gave, the slope was 3. Whenever I think about the number 3, when I talk about a slope, we always think of it as 3 over 1. A lot of times we'll have a fraction for our slope, like 3 over 2. In that case, my slope would be 3 over 2. My change in my y value, my rise, would be 3, and my run would be 2. The slope right here is positive. This slope would change drastically if I had a negative in front of it. Those are 2 of our 4 types of slope: positive, negative, 0, and undefined. Let's take a look at our 4 types here, some examples of them. Here's a positive slope. When you look from left to right, the slope is going up, 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 up. Here, for a negative slope, when we go from left to right, the slope is going down, 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 down. Just like we read, you read from left to right, you read slope from left to right. Slope is going up, 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 it's positive. Slope is going down, 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 it's negative. Sometimes slope is neutral. It's not going up or down. And if it's halfway between positive and halfway between negative, it's 0. There's no slope, not going up or down. The last kind is an undefined slope. You can see how this one is going straight up and down. The way you identify an undefined slope is that it's the only slope that's not a function. All three of these would pass a vertical line test, except undefined would not. Right here at the line, it would fail the vertical line test, and it wouldn't be a function. So the first three are functions. This one is not a function. And it doesn't have a y equals. Just like you guys graphed in the 3.4 day one, this one would not be a function. Here I have two examples shown for you. What I want to show you, and this is just a brief overview of our slope-intercept form, and then we're going to get into some specifics. I have 2/3 x plus 2. 2/3 is my slope. That means a rise of 2, a run of 3. My intercept is 2. Intercept. When we say intercept in slope-intercept form, we mean y-intercept. If it's the y-intercept, that means it's where it's crossing the y-axis. So that's this point. Makes sense. It's a 2, right? 1, 2, 3, 4. 1, 2. This is where it crosses the y-axis. This is my first point. It's always going to cross at 2. Rise over run. Rise 2, 1, 2, run 3, 1, 2, 3. I'm right in line with my point. It's right on my line. Here's another example. This time my y-intercept is -1. Where on my y-axis, where is -1? It's right here, right where it's crossing the y-axis. So that's my y-intercept. On this one, the slope is -2. That means we need to think about it as -2 over 1. Because anytime I divide by 1, I'm not really changing the value. My rise in this case is -2. 1, 2. My run is 1. That's right here. Notice I'm in line. Even if I started up here, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Throughout the whole thing, we follow the same slope of -2. How do we identify the slope and intercept? Let's take a look at a couple examples. I really want you to remember that your slope is always the value on the x. Your slope is always the value on the x. So I'm going to make sure I mark these. You need to make sure you draw a line connecting your slope to that value. I'm going to color them differently. Our slope is in green, so 2/3. Our slope this time looks like -2. But when I think about -2 as a fraction, it's tough to take a normal number that we like dealing with and think, well, really that's a fraction. But that's what it is. Whenever I have a normal number, a whole number, and I want to write it as a fraction, I put it over 1. So in this case, it's going to be 2 over 1. But since it's -2, I have -2 over 1. This is what our slope is. It means I have a rise of 2 and a run of 1, and it's a negative slope. Notice that connects here. Negative slope means it means to be going down from left to right. Let's take another example. Here's how I take not only just the equation and identifying the slope and the intercept, but how do I take that slope and intercept and put it onto a graph? Here are our 4 steps. You need to make sure you write down these 4 steps. So take a minute, pause the video, and write down those 4 steps. Here we go with step 1. It says identify the y-intercept and graph it. Where is my y-intercept? Let's think back. The y-intercept is always the one that doesn't have the x on it. My y-intercept in this case is 7. It's called the y-intercept. Y-intercept means it's where it crosses the y-axis. So where is positive 7 on my y-axis? 1, 2, 3, 4, 5, 6, 7. Step 2 says identify the slope. It means how is my graph changing from right to left? Slope is always the value on the x. In this case, 1 over 2. If I think back to my slope, it's always the change in y over the change in x. In other words, the rise over the run. Slope in this case is 1, 2. Rise 1, run 2. Rise 1, run 2. When we rise 1 and run 2, we actually start at that intercept value. Here's my intercept value. I rise 1, I run 2. And then I'm going to do it again. Rise 1, run 2. And I'm going to do it again because I can. Because I want to make sure that I go as many values out as I can. Rise 1, run 2. This is part of step 3. It says graph 1 point on each side of the intercept. It's easy to see here that there's a pattern. These make a very straight linear line. When I say I have a slope of 1 over 2, that's a positive slope. How do I know it's positive? It's not a negative number. Positive slopes always go up from left to right. This slope so far is going up from left to right. That means it needs to continue that path. So for my next spot, I know I needs to go up 1 and right, or sorry, up 1 and right 2, but I'm going backwards. So instead of going up 1 and right 2, I'm going to go down 1 and left 2. It's the opposite of both. And I can continue that. Down 1, left 2. Down 1, left 2. Down 1, left 2. Down 1, left 2. And it says to connect the dots. We connect our dots, we go to our line, make sure you use a straight edge so you have a nice straight line that goes through all of the points available. The more points, the more confident we can be that we've graphed our correct line. Now guys, this is where we really get different based on the type of student that you are. Some of you, based on the people that I've talked to, most of you got this and you're ready to go. You probably had this last year. Some of you are struggling with this concept. Talk to me. I am here to help you. I know there's a lot of students in the classroom, especially second hour, If you have questions, ask them so I can sit with you and go through these step by step. That's how I can help you to be a better mathematician and be better prepared for this chapter. Make sure you ask questions so I can help you. The rest of you, you got this. I believe in you. There is an exit ticket for 3.5 also, so just let me know when you're done and I can give you this. Tomorrow is a work day on this whole section. Please ask questions. I'm here to help you guys.